This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development.
This week, we have Leah Buechley from the University of Colorado, and her talk actually touches on two, I think, of the themes that we like to touch on here. One, we always talk about beyond the desktop, right? What is computing when you're no longer sitting in front of it typing at a keyboard, even a laptop? How does it fit into, quote, the ubiquitous fabric of our lives? And her work is very much looking at ways that the computer begins to play a role in the rest of our lives. And the other is design. One of the things that a number of our projects are looking at is how to make it easier for people to do design in interesting new interactive media without having to themselves build all the technology and build it from the bottom. And her work, what she calls democratization, looks at how you would not only build these sort of interesting and new kinds of devices, make it possible for lots of people to do that. And a quick plug, or do you want to tell them about the show tonight, or should I?
Go ahead. Well, we can multiply.
We can both do it, right? The reason we were able to get her to come speak is she's out here for a show at the Exploratorium in San Francisco, which is being held tonight. Doors open 7:30, and the fashion show, because it is a tech fashion show, will be at 9. And hers is only one of the many really cool things that you'll see there. So if you get a chance, go up to the Exploratorium tonight.
Thank you. So thank you all for coming today, and thanks for having me. I'm really delighted to have the chance to come visit Stanford. So yeah, the title of my talk today is Computational Textiles and the Democratization of Ubiquitous Computing. So lots of big words. Here, we'll break it down. So first of all, what the heck are computational textiles? I brought a demo to show you, and I just recharged it at lunch, but in a nice indication of kind of the perils of building hardware and kind of giving on-the-spot demos. I recharged the lithium polymer battery on the wrong setting, and it exploded. So it's all puffed up here, and it shouldn't be that way. But we can still I can still kind of show it to you. So this is a beaded bracelet. You can see it just looks like a traditional beaded bracelet.
You hold something down flat on the table, they got an overhead camera,
Uh-huh.
and they get a close-up of it.
Let's see. Is this the right area, or over here on this target?
Anywhere there, it's got a swivel.
Okay. So, and if we could dim the lights possibly, that would be ideal. So, yeah, so.
They dim the lights on that.
Turn the, so.
Oh, I see.
So it's a beaded bracelet, so a really traditional beaded bracelet that's soft and flexible. It was woven on a bead loom, so using really traditional handcraft methods. But as you can see, it also functions as a programmable wearable display. So I can shake this and kind of add some more lights. And we can do some different patterns. Here's one that probably many of you recognize. Kind of geeking it out. And just for interest's sake, here's the puffy lithium polymer battery. This is the sad sight. I don't know, you can't really see it, but yeah, it's sad. Anyway, so that's an example of a computational textile. Go ahead and turn that off. I should mention that I'll also use a couple of other terms interchangeably here. So these are also called electronic textiles, sometimes e-textiles, smart textiles, smart fabrics. We're still kind of as a field figuring out what to call ourselves, but I kind of like computational textiles. Here are a couple of other examples. So this is a jacket that I made recently that just helps me get around town on my bike. So this is a jacket that has turn signals in the back. So yeah, that's been pretty handy getting around town on around Boulder, because Boulder is a great city for biking, but the drivers, yeah, it's useful. This is a close-up of another device. This is a close-up, actually, of a touch sensor. And what I like about these examples is this integration of functionality with design. And we'll kind of come back to those themes. But this gets you started to kind of to get a sense of what the area is like. So these are all soft and really flexible things. So like the bracelet, you can see kind of how soft and flexible they are. You can see here that these are real items of clothing. So they're really made out of fabric. They're not wires. They're not hard things. They're really soft, flexible things. Okay, so the other chunk of the title, that democratization of ubiquitous computing. What do I mean by that? So I feel like my work is fitting into this fantastic tradition and also a movement that feels like we're gathering steam, and there's a lot of really exciting stuff happening kind of under this umbrella. So let me just show you a couple of these points. So I kind of think of this as a starting point. So Mitch Resnick and his group at the MIT Media Lab started to develop tools that allowed kids to experiment with building their own tangible computational devices. In particular, he started developing tools that allowed kids to build their own robots. So he developed what was called the Cricket, which is a little microcontroller and an assortment of sensor and actuator pieces that, again, allowed kids to experiment with robotics. And that project eventually developed into the popular Lego Mindstorms robotic kit. This is the most recent iteration of that kind of continuing work. This is the Pico Cricket, just the most recent version of that Cricket microcontroller. Here's another interesting point in this space. So while the Cricket work and the work that Mitch has done is primarily focused on kids as an audience, there's also been a significant amount of work that has focused on adults as an audience. And this is a picture of a device that in a lot of ways is really similar to the Cricket. It's a microcontroller, so it's a little computer that lives independently of the desktop, so it lives out there in the real world. But it's pretty easy to program and control this little computer. So novices, there's not a very high barrier for novices to get over to start to play with their own embedded computational projects, so their own ubiquitous computing projects using this little computer that's called the Arduino. So this is a familiar project. So developments in this space haven't been relegated to developments in hardware. There's also been a lot of interesting work in the software realm. So this is, yeah, I'm sure a familiar screenshot to lots of you. So this is a screenshot of D-Tools, I believe, so software that was developed here at Stanford. And this is a work in the space of connecting the hardware universe and the software computational universe. So thinking, there's of course the hardware side of empowering people to build tools that live out in the real world, but then there's kind of a software side also. So this is design software that lets you think about hardware prototypes kind of in the software realm, and then there's companion hardware that lets you prototype those devices in the real world. And then here's finally another really interesting point in this space. So probably many of you are familiar with Make Magazine. This is a fairly recent publication, and it's devoted to encouraging people to build their own electronic and computational projects. So it's a magazine that's filled with tutorials about how to build wacky electronic and computational things. So encouraging and empowering lots of different people to build their own ubiquitous computing systems, essentially. So there's all this exciting stuff happening in kind of different spaces. And I feel delighted and excited to be part of kind of this movement, I think, that's headed in this really interesting direction. So we'll kind of come back to these themes, but this gives you a snapshot, I think, of some of the stuff that's happening. Okay, so how am I contributing to this community? So let me just start kind of where I started. So I started working with computational textiles when I stumbled upon the materials, the basic materials that make it possible. So in particular, I discovered conductive thread and conductive fabrics. And it was kind of a revelation for me. And I just thought they were really fantastic, fascinating materials. And so if any of you are interested, I'll just mention I actually have a book up here with an assortment of all the strange and wonderful materials that you can kind of use in this universe. So all these different kind of electrically conductive threads and fabrics. So here's some of the, so here's some of the really fantastic conductive threads, and there's some really beautiful conductive fabrics. So let's show some of those. So it's a beautiful copper colored fabric. But anyway, if you're interested, you can kind of see some of those. So I found these materials, and I started to play with them, and I started to play with really simple things to start with. So building just simple electrical circuits on fabric. But kind of in conjunction with my exploration of the medium, I felt, gosh, this stuff is so cool, other people should be doing this. And it's not only, it's so cool and it's so new and fresh, but it's also really accessible. So these materials are really simple to use, just people don't know that they're out there and people don't know how to get them. So how can I start to introduce other people to these cool materials and kind of to this cool new universe that I had discovered? So I developed with a colleague of mine at the University of Colorado, we developed the electronic sewing kit. And this is kind of what it looked like. So it consists of a little battery that's in a battery holder that is easily stitched to fabric. We made a little soft fabric switch out of some conductive fabric. So that's what you see there, that little red button. Some conductive thread. So that's the gray thread you see there is a traditional nylon thread that's coated with silver so that it conducts electricity. And you'll have to come up afterwards and feel some of this stuff because it's really thread. It's not wire. So people think when I say thread, I really mean wire, but it's not. It's really soft and flexible like a traditional thread. And then finally an LED that's been modified a little so that you can easily sew it to fabric. So we developed this kit, and then we went out and we worked with different people and had them sew circuits and kind of saw what they could, how they choose to use these materials. Yeah, question?
So I envision as single conductor.
As what?
Single conductor thread.
Yeah, so it's just like, aluminum foil or something. Yeah.
Yeah, well, okay, so I was just wondering what the ground, so you have to have a thread for the return and a thread,
Yeah, so so this is, in a sense, it's electrically just like wire. So if you want to make a circuit, you have to sew one end of the thread to the plus end of the battery, sew that to like one end of your switch, tie a knot, put some glue, then sew, from your switch to your LED, tie it, put some glue, kind of come back around to the battery. So yeah, is that?
Yeah, it's very different than traditional sewing.
Yeah.
You can't cross wires, right?
No, so that's a whole host of issues, yeah. And come up and see the materials afterwards, and yeah. But so we did a lot of workshops, and primarily with kids ages 8 to kind of 20. So we did a lot of work with kids, and here's an example from one of the workshops. So we would just give each participant a sewing kit and an assortment of craft supplies, and they would decorate stuff that they brought in from home. So you can see these two kids decorated these caps that they built, and they put a switch in the back so they could like tap their caps and the lights would flash. But it quickly became apparent in these experiences. I mean, it was kind of apparent from the beginning, but it became more and more of a pressing issue that working with simple series and parallel circuits is extremely limited. It's not terribly interesting after a while. So, while kind of in conjunction with those experiences, I began to explore the possibility of kind of developing more sophisticated design using these materials. So you saw the bracelet there is an earlier version of the one I showed here. So I began in particular, as you can see, to explore building wearable displays out of these materials and soft, flexible, kind of washable wearable displays. So shown on the left is a shirt that has 140 LEDs that are sewn kind of around the midsection of the shirt. But keeping in this tradition of democratization and trying to think about how this stuff could remain accessible and open, when I built that green shirt, I documented my building process in a really detailed way, in part inspired by publications like Make Magazine. So I took pictures of how I was modifying the LEDs and how I was sewing things on, and how you could use fabric paint to insulate the threads when you stitch stuff together. And when I completed the shirt, I also posted on my website a tutorial that explained how anybody could build their own shirt like this. And I was really happy to get a lot of response from that posting. So a few days after I put it up, I started to get emails from people around the world saying, got a really diverse group of responses, actually. So one email I got was from a grandmother, and she said, thanks for putting up these instructions. I'm going to use them to put lights into these Teletubby handbags that I'm making for my grandchildren. And then another email that I got, I think on the same day, because this was a juxtaposition that just stuck in my mind, was from an electrical engineering graduate student. And he said, he wrote to me and he said, why are you using an if-else statement in your game of life code here? You should be using a switch statement. You could optimize this. So it was very intriguing to me that I had kind of captured this strange and diverse audience, and that it seemed to strike a chord. A lot of people seemed to be really excited about this medium and interested in building something. So let me just take you through one kind of experience I had with one person in particular. So I had this long correspondence with this woman from Australia. This was kind of the first email she sent me. So she says, thanks for publishing your how-to for the wearable LED display. I'm learning all about electronics a little late. I'm 26. In order to make your LED display, I've sort of taught myself, starting with a basic kids LED kit. So you can see this is where this woman started. Now let me show you a video of her final project so you can see where she got. So I think, so a couple of things are noteworthy here. First of all, I love that as a cultural snapshot of the audience that I'm reaching here. I love this punk club fashion show, you know, the audience here that she's reaching. It turned out she was a bartender at this goth club in Australia, and they had a fashion show, and she made those dresses for it. But then I also want to stop and make a note about the technical accomplishment that this was actually. So each one of those skirts had kind of 4 rows of LEDs and 10 columns around. And they worked. You can see that they worked. She programmed them to have this kind of cycling pattern. But all the LEDs worked, and it was successful. You can see people wore them. So it's a fairly simple project, but this was actually an amazing accomplishment. So let me tell you a little bit more about the instructions that I posted. So the instructions that I posted on my website that led people through how to do this, to do this project, you had to, first of all, download and install the AVR GCC toolchain. And to do that successfully, you had to worry about things like your path variable. You had to do all the installation via command line, kind of Unix style if you were working on a Mac, which was the instructions that I posted. Yeah, so that was basically a total nightmare. The hardware side was equally bad. So you bought a bare AVR microcontroller from DigiKey. That's what I suggested. You also bought a big clunky hardware programmer, and you had to kind of unplug your chip from your garment, put it into this big hardware device to load programs, and you had to do all the writing of code via kind of a text editor, and then the compiling via command line interface and the loading via command line interface. So it was really kind of hardcore CS style thing. So the whole thing was a nightmare. So this was I was so excited that this happened, but much more common was experience like this. So this is another email that I got. So I have some trouble following your steps, and I hope you will give me some quick advice. In your step number 4, I can configure but not install GCC on my Mac G4 running 10.3.9. Yeah, I get this crash. Please, can you help me? So I have no idea what this guy's problem is. I can't help him. I really don't want to spend my time, honestly, trying to figure out what his problem is. But I feel horrible because I kind of, in my posting, made a promise. I was like, oh, here's this really cool thing. I think it's great. It's new. It's exciting. You can make this awesome thing. And then I led people to this miserable experience and this miserable failure. So this really made me stop and think a lot more seriously about making things accessible. So in particular, it led me to design what I initially called the e-textile construction kit, which then turned into the Lilypad Arduino. And here's what that looks like. So what the Lilypad Arduino is it's a construction kit that makes it really accessible to actually build your own electronic or computational textiles. So at the heart of the hardware of the construction kit is a little microcontroller, but it's a microcontroller that's specially made for sewing. So this is what it looks like. Each one of those little flower petals is an input or output pin from the microcontroller. And what you do is you can sew that microcontroller to other similarly packaged sensors and actuators. So there's a little temperature sensor. There's a light sensor. There's a fabric switch. There's some a vibrator motor and some LEDs and a little speaker. This is an on-off switch that's made out of conductive Velcro. And this is an infrared transceiver that allows wearables to communicate with each other. So that's what the hardware side of it looks like. And here's what the software side of it looks like. I want to be clear, I didn't actually develop the Arduino software, which is what you're seeing here. The Arduino software is part of a larger Arduino project. So the Arduino, you saw the board in my introduction. So there's a hardware board that's called just the regular Arduino board, and then this companion software. So I kind of piggybacked onto their project and based my hardware around, kind of emulated their hardware platform so that I could easily plug into this existing software. So this is what it looks like. So what do you do with it? So here on the right, this is actually a close-up of the piece that I'm going to be showing tonight at the Exploratorium. So that's a close-up of one of the fabric Lilypad Arduinos. And you can see there how you sew things together. So you can see the stitching there in the conductive thread, how the attachments are made. Shown on the right there, that's an example project, kind of the types of things that are really easy to build using this toolkit. So this is a hat that has an RGB LED and a pom-pom, and that's temperature sensitive, so as it gets colder, the pom-pom turns blue, and as it gets warmer, the pom-pom turns red. So I built this kit, then it's kind of, so what did I do with it? So I built the kit, and then I did a bunch of workshops with the kit. So I held a bunch of classes that were called Learn to Build Your Own Electronic Fashion. So in particular, I taught 2 high school classes through local high schools in Boulder, Colorado. In those 2 high school classes, I had a total of 21 self-selected participants. Interesting to note that 16 of them were girls and 5 of them were boys. So keep in mind that this is really an embedded computing class, yeah? And you don't usually see those kind of gender statistics for embedded computing. So I also,
You put on a bias. Sorry.
But let's see, I also taught 2 day-long workshops with adults with 9 invited participants, so the gender info there isn't too interesting. I mean, it's not relevant. 1 week-long workshop with teens and adults with 7 invited participants. And then finally, last summer, 1 week-long workshop with a group of teenagers. 10 participants. Out of those 10, 9 were girls. So again, remarkable. So the evaluation that I did was primarily usability. So is the kit usable? Can people actually build stuff with the kit? What kind of things do they build? Starting to look at educational potential, looking at gender enrollment, and then student motivation. So, I'll come back to those in a second. So I did some pre and post surveys and looked at the enrollment statistics and then tried to document the projects that the students made. So this was what a course would look like. So part of what I did was also develop a curriculum for this kind of experience. So we would start with a whirlwind introduction to electronics, programming, and the Lilypad. I should also throw sewing in there, so that was part of this intro. So here's kind of roughly what part of that introduction would look like. So kids would be given a kit and some sample I/O devices that they would clip together with alligator clips like this, and then they would work from some starting sample code examples and kind of modify the code to get a sense of how it worked, and then kind of go from there. Then after people had a sense of what was possible to make with the kit, we would go through this design and prototyping session. So I modeled the courses on a Lego Mindstorms kind of robotics course. But it turns out there's this really important difference between this medium and Lego robotics or kind of other common mediums that are used to introduce kids to electronics and programming. In that when you're working with textiles and you start to actually sew stuff together, you're making a huge commitment. So when you sew something, you really don't want to go back and unsew it. It takes a lot of time to sew stuff together, and it's actually hard to unsew things, and then it's, you know, really time-consuming again to sew them back together. So you can't do the same sort of iterative building that's so easy to do with Lego Mindstorms. It's a much more traditional kind of engineering cycle where you have to be really thoughtful about design and thoughtful about prototyping. And when you commit to building, you're really committed and you really are making a serious investment. So these are some just images from some of the design sessions that we went through, so some sketches, and you can see how prototyping again took place using alligator clips. And then finally, go through this construction and debugging cycle. So here's some kids working. Here's a partially completed design, and you can see that the debugging half of that title is really important. So getting back to your comment about the uninsulated thread, yes, and you can see those knots that are tied to the positive and the minus leads on the microcontroller are pretty dang close to shorting each other out, and that's going to cause some problems. Here you can see how you can use alligator clips while you're sewing stuff together to kind of prototype and build in tandem. And then finally, this is a close-up of a finished design that was built by a 13-year-old girl in one of the workshops. And here we kind of come back to that theme of design. So I really love the way she integrated the electrical and aesthetic components here. So these stitches are all functional electrical connections, but you can see how thoughtful she was about making them part of the aesthetics of her design. And then finally, each class would culminate in a fashion show. So kids would get to show off what they made to their family and friends. So here's some images from those. So I like these guys. They were so tough, but they had a good time. Here, this girl is explaining what she made. Yeah, so I love this picture actually, and I'll come back to a theme that I think this highlights. But this shows two participants playing with the wearables that they built and kind of having fun around them. So what's happening in this picture is the girl built the shirt. The shirt uses the Lilypad, and what it does is that when someone squeezes her waist, it makes these silly sounds. So this was this workshop I did with a group of teenagers, and we focused on using these touch sensors. And at the end, the teenagers just had a blast playing with the things that they had built. They were really thrilled to have this opportunity and excuse that this provided to touch each other and to flirt and kind of feel each other up. And so I was lucky enough to capture this flirtatious moment that centered around the wearable device. But I think this brings up this brought up for me some really interesting issues and some really interesting potentials of this medium. So I'll come back to these issues in a second. But let me show you a little video of some of the stuff that people kind of over the years have built in these workshops.
Oh, that's great.
Very cool. Color changes with that.
Yeah, and then hopefully this one will actually work. And then when I open my bag, I've got light.
And they're controlled by this like Velcro, so it's
switch.
one that is
Hey, I'll bring them together for you. You can maybe take them.
excellent.
Are you doing video?
Yeah.
And then I don't know if I'll be able to get it to stay open and off. Let's see if I can actually attach it and lift it up for you. Oh, and this thing should go off if I unattach. Oh no, I didn't do it that way. Boop, boop, boop.
Most definitely. It never lies.
Wait, let's do one more question here.
All right, what do you want to ask it?
Doug, did you enjoy sewing this shirt?
I know what that answer is.
Do you notice that the probably doesn't go on the blank?
Uncertain, ask again.
Oh.
What did you say?
Back.
Lâchez.
Ouais. Eh,
Remettez.
some language. Ouais. Ouais.
Lâchez les mains là.
Là, oui. Ouais. Eh, again.
On touche
No.
quand même. Ça
And
va encore, prenez les
voilà.
mains.
Ouais. Yeah, so that gives you a sense of some of the things that people were building in these workshops. So here are just a collection of some of the feedback that I got on the surveys, so about people's experience with the class. And so I just want to highlight a couple of these quotes that I think point to interesting themes in this work and also pointers to kind of continued areas of research. So first of all, was there anything in the class that you found particularly hard to do? Programming emerged as a continual struggle for several students. So this second quote there is particularly kind of piercing, I think. So I had a ton of trouble computer programming. It was very confusing for me. As you can imagine, also reflecting back to that image that I showed of the Arduino programming interface, the Arduino programming interface does a lot for you, but ultimately you're still programming in C, and you have all the problems that entails. So there's definitely a big opportunity there to make that part of the experience better. So it would be great if kids could use Scratch or Alice or something like that to do the programming of their constructions. So I think that's a big pointer to a future research. So some interesting quotes here. First of all, did see some of the flip side. So it seemed like at least some of the people who came to the class, probably wouldn't have ever signed up for a programming class, but when they got there, they enjoyed it. So this girl, for example, I think I might take a future class in electronics or programming because I thought programming would actually be a lot harder than it really is. And then I love this quote here. Yes, because I intend to be an astrophysicist or a mathematician. Also, I'm interested in fashion design and modeling. So that quote to me gets at some, quintessential chunk of what it means to be a girl, just certainly in the States. And I think the fact that this experience can tap into those kind of conflicting impulses that girls have is powerful, that there's something to think about and take advantage of there. So not everybody was super psyched. So this girl, Shauna, she wasn't that into it. She came to the class. She was like, it was okay, but it's not my favorite thing. So But some of the kids were really enthusiastic, so that was exciting. So this last quote in particular, I want to point your attention to. So this is actually an email that the kids sent me a couple of weeks after the workshop had ended, and he just sent me this random email, and he said, "I just wanted to tell you that my friends thought my hat was so cool. So I loved your camp." So just let me explain briefly what he built in that workshop. So he actually built a very boy project. So he had a New York City Police Department hat, and he put a speaker on it, and then he had this switch where he'd press the switch, and every time he pressed the switch, different siren noises would come out. So that was his project. But so what I think is interesting here is that he built something that he then took and wore around in his day-to-day life, and his friends thought it was so cool. So he participated in this activity that was this, sophisticated learning activity that involved programming and electronics and sewing, which was really new to this guy. And then he had this experience, and he was left with something that made him feel cool and that his friends thought was cool. So again, I think there's something really powerful there that we can take advantage of and think about the social roles that these types of handmade and wearable artifacts might take on in people's lives. I think thinking back also to that picture of the kids flirting around the wearables is interesting. So again, thinking about the social role that these types of devices might play and how we might take advantage of that and kind of support it. And I don't know, I think there's rich territory there. So this was all great. I really enjoyed these workshops, and I had a lot of fun teaching them, and it was fascinating to see what the kids built. But for me, it was also really frustrating because I felt like I wanted to hold more workshops, and I wanted to be able to work with more people. I wanted other people to be able to have these experiences, but there was this huge accessibility problem. So each one of these little patches, each Lilypad Arduino module, I built by hand. So it's funky little techniques that I developed for making fabric circuit boards and then soldering surface mount components to the fabric circuit boards and making a little cast thing that solidifies the solder joints. And each one of those would take me like 2 hours to make or something. So to do a workshop was this huge investment of labor. So there was a big scaling problem. So yay. After thinking about it, I'm lucky enough to live in Boulder, Colorado, which is also the home of Sparkfun Electronics, which is a fantastic electronics store. And I just went to them one day and I said, "Look, I have this thing and I want to make a commercial version of it. You want to partner with me on this?" And they said, "Yeah, sure." And so there is now a commercially available version of the Lilypad Arduino. This is what it looks like. So unfortunately, of course, it's on hard traditional circuit boards instead of fabric. So that's kind of the downside. But the plus side is that it's actually available, and lots of different people can now actually build their own wearable and other soft computational stuff very easily. So what it consists of right now is the main board, so the microcontroller component, a power supply, a light sensor, a little vibrating motor, an RGB LED, a little speaker, and then an accelerometer. And I'll just mention, yeah, also, well, I'll put one on the monitor, and you can come up and see one in person too. But let's see, get a sense of the scale here. Yeah, so here's my hand. Here's how big they are. It's actually a slightly different version. The main board has changed a little bit since when we first released it last fall. But I'll also mention, so this So my target audience for this was novices and especially kids, but you can really easily extend this to do all sorts of more sophisticated projects. So I'll just mention a couple of kind of cool extensions. So there's a little Bluetooth module. So really easily you can plug that Bluetooth module. You can plug its connector there using some kind of just female jumper cables. You can plug that right into the kind of male cables that are on the main board, and then you have a wirelessly enabled wearable device that can talk to other things via Bluetooth, so like phones and laptops and whatever has Bluetooth. So that's kind of nifty. This is a little data logger board. So that board takes a tiny SD memory card, and for like $18 or something, you can get a gigabyte of memory on a flash thing that slides into that board. And that board also you can plug right into the Lilypad. And I don't know, you can log a lot of sensor data on a gigabyte there. So that's kind of cool. Okay, so that gives you kind of the specifics of what I've been doing for the past few years. But I want to return now to this theme of democratization and just think about how this fits in. So I'm going to start by thinking about this. So what's wrong with computer science? Yeah, well, from my perspective, I don't know, let's look at a couple of traditional CS type things. So there's /dot. Yeah. Here's, okay, this isn't exactly computer science, but there's some computer hardware, right? There's some nice computer sciencey stuff. There's some compiler garbage that got spit out at me if I deleted a semicolon or something. Oh, and there are these really cute boys working on their Lego robot projects. I can't pick on them. They're so cute. They're great. But still, when I look at all these pictures, I don't know, a few things jump out at me. So first of all, like the color palette here, it seems kind of impoverished. So, also accessibility. So, okay, yeah, we all know like command line interfaces, they're not terribly accessible. They're really hard to use. But I think maybe much more importantly is the cultural inaccessibility that comes across in these images. So /dot, not so culturally accessible. I don't know, there's a lot of misogynist stuff on /dot. /dot's great, you know, it's awesome, but it's very limited. So, and it's not very accessible or friendly to outsiders. Yeah. Here again, there's not only a practical inaccessibility, I think there's a cultural one. So there's, again, this kind of hacker culture of being badass and doing Linux and whatever. So, and then here, so again, I really can't pick on these guys because they're awesome, but I think this is culturally not so accessible. So I was probably actually a lot like those boys in that picture when I was a kid. And maybe a lot of you were, probably most of you were a lot like those boys. But everybody's not like that. And we shouldn't restrict our definition of computer science culture, like to be equated with these things just for cultural reasons. So the way I see it is that we can kind of keep all that stuff, but we need to also expand. So to include stuff that looks like this, and people who are kind of looking like this and maybe interested in other things, things that look like this, and people like this. So yeah, I feel like we just need to grow, and we need to be culturally open to things that look a different way and feel a different way. And that when you make technology look a little bit different, and when you name it a little bit differently, so when you call it fashion, people come and they have a great time, and you get really different people to come and have a great time. So we can make this change and we can grow. And I think it's really more about culture than it is anything else. Okay, so I just wanted to acknowledge a few people. So first and foremost, my fantastic PhD advisor, Mike Eisenberg. Also, just ongoing collaborators. So in particular, Nwanoa Elumeze, who's another PhD student who I work with a lot, and the Arduino people and Sparkfun and all sorts of other, all my undergrad assistants also, they're awesome. But thanks a lot for having me today, and any questions? Uh-huh.
I was wondering, outside of the students playing hanky-panky, touching each other, was there any sort of other things they made or interactions that they've done that surprising that you didn't anticipate? Like a conductive chain or?
I mean, there've been a lot of like kind of ongoing like small like revelations and all sorts of. So one was like using like hair ties as a switch. So somebody made something that was like just these dangling metal beads off of like a ponytail thing that worked as a switch that was kind of like a motion sensor. And so that was really like exciting. So I feel like continually there are kind of these little engineering revelations that are really neat. Just how people think about using the materials and using computation. I have to say that this all, in a lot of ways, this all feels really young, and I feel like we're just, or me especially in my workshop with kids, I'm just at the point of being able to have longer experiences with kids or work with kids who like build something and then come back to build something else, and I think those experiences will be really, I'm really interested to see what comes out of those experiences. I feel like right now we're kind of at this like baby project stage, and I'm curious to see what the next steps will be, kind of. So, yeah.
Just a quick, simple question. You said those are available commercially.
Yeah.
Where do you go to get them, and how much do they cost?
Yeah. So you can get them from from Sparkfun, which is an online electronics retailer. There are also several. I mean, there are a few other distributors in Europe and Canada and stuff as well, but Sparkfun's the main US one. And then sorry, let me just go back to the picture of the board. So you can buy a kit that has like conductive thread and power supply and main board and the RGB LED and the light sensor, and that's $80. Oh, and it has a programmer, the little programmer attachment that you need, and the like USB cord. So that's $80 to get started. And then you can also buy each component separately. So we tried to make this as cheap as possible. And what that boiled down to is the main guy is $20, about $20. And then the sensors and actuators depend on price. So the accelerometer is the most expensive one. That's about $25. The light sensor is like $7. The RGB is like also like $7 or something. I think the buzzer is $15 because those little motors are hard to get cheap, and then so things kind of vary. The power supply is like $15 also. So. Mm-hmm.
You've held yourself accountable. I mean, the amazing thing about this work is that you've held yourself accountable to very different ways of being. There's craft, there's activism, there's manufacturing, there's teaching, there's ability. And I was wondering if you had any thoughts on negotiating being accountable to all those different things simultaneously.
Yeah, I feel like that's a, well, I guess as a researcher in academia, it's been really important for me to have a relationship also with the real world. So that has, so I've felt just like something personally for me, I really wanted to like, you know, make this stuff truly accessible and kind of communicate with the real world and not stay in academia. I feel like that, so that has, so I've been, at the same time, that has been sometimes difficult to balance with the life in academia because you know, that's kind of, that's from a different life, so you have to devote time to it and thought to it and energy to it, but it doesn't really help you in a direct way in academia. I think it eventually comes back around to help you, but it doesn't help you right away get a paper published or anything. So, so I guess the biggest struggles that I've had in that area have been in terms of like smaller ones, though I think, but though they're definitely getting better in terms of like publication expectations. So submitting a paper and having, say, one reviewer say, oh, this is really interesting, but you know, your usability sucks. Your usability evaluation sucks. Or submitting it to an education conference and having the people say, oh, this is really exciting and interesting, but you're not talking about learning and what people learned. So, so it's been interesting to navigate that, and it's kind of, I don't know, a lot of it seems like the luck of the draw in terms of reviewers, but it's doable at the same time. So sometimes, so yeah, it's kind of a continual balancing act. So, but I'm not willing to, I mean, especially, yeah, I mean, I definitely had a lot of advice from people who are like, pick a community and like live in that community. And I just don't want to do that. So I'm trying to make it work. And so far, so good. So I don't know, perhaps you have insight on that as well. Mm-hmm.
Currently, your project is just focused on the normal people to make their own designs, right?
Mm-hmm.
So what if you just give the ball to the real designer? I mean, the professional designers do this stuff, then you don't have to worry about any accessibilities or training. You just only train a few people working for Ralph Lauren, and they can make this stuff and sell cool things to us, right?
Yeah, I guess, I think that would be really exciting to work with designers, and I mean, I've at the same time, I do feel committed to like this kind of popular audience, and especially to kids, because I think there's, I mean, I guess, you know, in a longer term vision, I'd like to somehow make an impact on like having people rethink, you know, technology and have a broader kind of impact, I guess, with some of these things than just like a narrow design audience. That being said, like the experiences that I have had that were more like that were really just wonderful. So to be able to work with people who are, you know, really like proficient designers and really creative, that's been really exciting as well. So if the opportunity presents itself, I'd love to.
Why don't you try people, a student who is to be a designer, right?
Yeah.
They're in design school, right?
Yeah, I think that would be great. So some people, the Lilypad actually is being used in some contexts like that. So, but I haven't been teaching those courses. But I would love to have that opportunity. I think that would be a really fun group to work with, and the fact that the kit is available now would make it possible for, you know, other people to use it in that way. So. Mm-hmm.
What sort of computer science course, high school oriented or junior high oriented computer science course would be appropriate? But this would be a good progression.
A good progression, like.
Yeah, I mean, so now you've got this kid think, cool, more computer science. What's the next thing they should enroll in or next thing they get involved in?
Yeah, that's an interesting question. So I guess I like to think about that outside of traditional curriculum. So that, because it's easier for me to do that, and I don't think that necessarily the existing curriculum fits the path very well. But just some pointers to where this might go for like an advanced student. I think these sidebars start to hint at possibilities. So a student could start to think about activity recognition. So, and using, say, maybe exemplar, start to say, and like a Bluetooth chip or a data logger, say, okay, I can get all this accelerometer data. I can plug this data logger in and like put an accelerometer on my foot or something and walk around all day. Now, how can I see what I did? Like I have this data, how can I see what I did from that data? And that leads to all sorts of exciting computer science topics. So I think there are lots of like sophisticated questions that this nicely ramps up into. So I like to think along those lines, like I guess more along the lines of projects than classes per se. But I think that there definitely is kind of, you know, a high ceiling there for people to explore.
Thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.